What does it take to understand the invisible world? The viruses shaping our lives, sometimes without us ever knowing. For some, it starts with a double major in biology and chemistry, a curiosity that led them from Cincinnati to Nashville and then to Atlanta. Along the way, there's a PhD in microbiology and immunology, dissecting the structure and function of coronaviruses, years before the world would come to know their names. A doctoral thesis titled Structural and Functional Analysis of Coronavirus Cysteine Protease, NSP5. Not exactly a light reading, but the kind of work that quietly builds a foundation for breakthroughs. At Emory University, this scientist played a central role in developing a live attenuated vaccine candidate for RSV, a virus that threatens infants and the elderly. And while pushing the boundaries of virology, there was also teaching, MCAT and DAT prep, and time as an adjunct professor, helping the next generation of scientists find their footing. Now, as associate professor and virologist at Butler University, he specializes in virus structure, stability, and function. But this story isn't just about the science. It's about the questions that keep us up at night, the twists and turns of a career, and the challenge of building public trust in a world full of uncertainty. From PHI Media, I'm Gordon Thane, and joining me for a conversation is Dr. Christopher Stobart, someone who spent his career at the intersection of research, teaching, and the relentless pursuit of understanding the viruses that shape our world.
You're listening to the Public Health Insight Podcast, your go-to space for all things public health and global health, from the Sustainable Development Goals to the social determinants of health, as well as interesting dialogues about the diverse career opportunities that exist in these fields. Remember to subscribe to the podcast and leave us a rating on Apple Podcasts and Spotify so other people like you can benefit from our content. Dr. Stobart, welcome to the Public Health Insight Podcast.
Thank you for having me.
Awesome. I had your colleague on, I think last week, Dr. Barnard. There's some undertones of obviously misinformation to the vaccine discussion, the measles, the vaccine preventable disease discussion. But I'm really particularly excited to explore the science behind how disease spread and what people might get wrong with how they think about disease spread and what kind of works for prevention and treatment, as well as the science of vaccines, which is something that's been around for a while, very thoroughly researched, but the public trust in vaccinations isn't where we probably need it to be. And I think that's a fascinating conversation to have. So we'll get there. But I want to start with something right up front. I was trying to wrap my head about what's the story behind this. So in researching about your background in education, it seems like you had a particular interest in biology and chemistry. Did you end up doing a bachelor's with a double major, or you did two separate bachelors? What's the story behind that? I couldn't quite figure that out.
It was a double major at Xavier University in biology and chemistry. And I mean, I love science. And, I went into college originally as a pre-med. I wanted to be a physician. And, you never know what kind of curveballs are going to be thrown your way as you start jumping into your education. And I challenge anyone who is an undergrad to go into college with an open mind, because sometimes you'll find your path leading you in different directions. And in my case, I went in thinking 100%, I'm going to be a doctor, I'm going to be a surgeon. That was the plan.
Okay.
So biology and chemistry are two of the main disciplines that you have to take a lot of classes in to prepare for the medical placement exams. So normal path as a pre-med. What I didn't anticipate was teaching opportunities that would come my way, opportunities to lead small discussion groups, and opportunities to connect with students through education, and really falling in love with that facet of my experience. And so these came to a head actually junior year of my college. I was still thinking I'm gonna be a doctor, but I'm starting to think maybe I'd like to do this education piece. Maybe I'd like to divert to something more in higher education. And ultimately I decided to apply to graduate programs, PhD programs, rather than medical school programs. And that, the rest is history, as you might say.
So tell me about the initial interest in the pre-med angle. Yeah. What inspired you is that more the lack of imagination, I guess, that a lot of high school students experience being pigeonholed into like the 5 major types of career, or that you had different role models or interests specifically in medicine and surgery, and that's why you wanted to pursue that? Was it kind of one of those pathways?
I think the human body and physiology is just fascinating. I mean, you think about us as human beings, we're complex,
Right.
extremely complex, right? I
Right,
mean,
right.
you look at the science of how do we think? How do we run a marathon, right? I mean, how does the human body allow us to run 26.2 miles and not drop
Mm.
3 miles in? Being able to keep our heart beating our entire
Okay.
lives, right? I mean, I
Right.
was interested in being a heart surgeon. And while one might refer to that as maybe a glorified plumber trying to fix clogs and leaks somewhere in the system, of course, making a lot more than a plumber. But the reality is that the heart is an amazing thing, as is
Mm.
a lot of the things that go on in
Right.
our bodies. And so at a young age, I was just drawn to how does our bodies work? I was always asking questions. I mean, every scientist begins with that initial desire to, I want to know how the world works. I want to ask questions. I want answers.
Right. Right.
So medicine was a natural direction for me. Now, one thing you're alluding to, which is certainly a factor in my case, I never saw myself pursuing a PhD in sciences initially, nor do most kids coming out of high school. You go through high school and there's in science, there's the traditional paths. You can be a doctor, you can be a dentist. You don't
Yeah.
anticipate being a virologist. It's not something that's on the radar of a 17-year-old applying to
Right. Right.
colleges, at
Right.
least not
Right.
usually.
Right.
So for me, it was just that natural connection with science and wanting to know more about the human body. And I think that's also why when I did divert from that path of pre-med to that
Mm-hmm.
path of pursuing higher education, I chose virology. I chose viruses
Mm.
because viruses interact with humans in so many
Right.
different ways. And of course, you bring in the complexities of medicine while also adding in those layers of science, which are
Right.
really cool and interesting. And
Right.
and I think that's what pulled some of those elements together to help me get over that bridge of, do I want to be a scientist? Do I want to be a doctor? Do I want to go this path or that path? I think it was a way of finding a middle ground that for me was a calling that worked.
I can relate to that. I remember in one of my upper year virology classes, or maybe it could have been second year, learning about there's remnants of our DNA that are derived from viruses. I have viruses in my DNA and they've been there since I've been born. I can understand the fascination specifically with viruses.
What you're talking about 10% of our genome we think is just virus remnants, virus crap left in our
That's
genomes
crazy.
from years and years and years of humans being infected with viruses. We don't even know what most of those do. So imagine 10% of your genome, we have no clue what these things are doing.
Right.
And this is the frontier of
Hmm.
virology today, trying to figure out what's going on. We have the human virome, which is
Right,
the
right, right.
viruses that we're constantly infected with or living within us. Most of them we don't think do anything major,
Hmm.
but we carry them. Are they? There's questions of, are some of these neurologic viruses the causes of some of the neurologic disorders, such as Alzheimer's, dementia? There's a lot of questions that are just
Mm.
hanging out there we don't have answers to. So yeah, virology is an area that I think is fascinating
Fascinating.
and
Yeah, I agree. I
certainly
agree.
a calling.
But now it seems like you didn't fully give up the medical pathway from the standpoint of you taught some prep courses for the Princeton Review. Like,
Yep.
how did you go from, okay, grad school, I'm going to pursue that, but I'm also going to teach folks how to do the exam you need to do to get into dentistry, get into med school? Like, how did that come about?
Yeah, so I took a Princeton Review MCAT test
Yeah.
prep course. A lot of pre-meds do get
Yeah.
that score because you don't get the score, you're not going to get in. So I took that exam, and afterwards, I was kind of again having this two-sided battle within myself. Like, am I going to be a doctor? Am I going to go into higher ed? And it just seemed like a natural place. I was like, I enjoyed the disciplines covered in that
Right,
MCAT
right.
test prep, covering general biology, general chemistry, physics, organic
Mm.
chemistry. Teaching those was a way for me to connect with the content, to go deeper into understanding how it works, and also to explore teaching. Because, I mean, what teaching opportunities exist for someone who is 21 or 22 as an undergrad? I can't get hired as an adjunct professor without a college
Mm.
degree. I
Hmm.
can't teach high school because I don't have a college degree, but I really wanted to teach and get into education. And so that was an avenue for me to explore that option, to teach a classroom, to think about preparing a lesson plan and connecting with students, and also
Hmm.
just
Hmm.
having those conversations. Like, helping them see how the world works is cool. And it's unfortunate, but a lot of students that go through college classes and it's very prescribed disciplines, especially, for instance, physics. Physics is a perfect example because often physics professors, it's all about plug and chug. I'm going to give you an equation, you're going to plug numbers in. And those calculations, it doesn't explain how it works. It's just you solving math problems.
Right. Like isolated from the real world kind of
Right.
workings. Yeah.
Right. But then explaining to someone, okay, how does gravity work? How does forces work? Those opportunities were of interest to me, and I found more merit and enjoyment in teaching in that capacity. So that's why I pursued that. And then through my grad school studies, continuing that, honing that skill, thinking now I'm going into higher ed, I want to make sure that I can be the best teacher I can. I can think how you best explain things, how do you connect with students, and how do you address the issues they might have in trying to comprehend those difficult concepts.
So you go from, I want to have some teaching experience with, at the time, only your undergrad degree,
Yep.
to now you're at Butler as an associate professor in the university's Department of Biological Sciences. What areas do you focus on in terms of the courses that you teach? And like, tell us a little bit more about the research that you do.
Sure, yeah. So Butler University is a primarily undergraduate institution. We have just shy of 5,000 students. And so most of the students that I teach, by and large, are going to be 18 to 22-year-olds working. A lot of them are pre-health, but there are students who are interested in going to ecology, going into other fields of science. And so I teach introductory level courses in genetics and cell molecular biology. I teach upper level classes in virology, microbiology, parasitology. The goal is to expose them to as many facets and pieces of science to broaden their horizons of the world around. So for me as a microbiologist, it's bringing that part of the world they can't see into life, right?
Right.
Me, I enjoy it. It's fun to connect with these students. And of course, every year gives me another glimpse of the next generation and their perspectives and how their world has been shaped by their experiences. COVID-19 completely changed kind of the way the college students started thinking about things, right? Because now they're forced to embrace a new reality of society and culture. But that also brings really cool conversations into the classroom that we may not have never ever had. So that's something that keeps me excited and in my career. I mean, those are the classes I teach. Now, I do have an active research program. Again, at Butler, it's all undergrads for the most part doing that. Occasionally, we have a pharmacy program, so I'll have a doctor of pharmacy student in there, or we have some PAs that might jump in and help. But mostly it's undergrads, and we study viruses as a virologist. And, we have a virus system, but two main virus systems we've been studying are respiratory syncytial virus, which is a human respiratory pathogen. It's a major pathogen of infants and the elderly, but it can affect also immunocompromised and immunosuppressed adults. And it causes mostly pneumonia. It's the main concern is secondary pneumonia caused by bacteria after infection onset. And then the other one we study is a mouse coronavirus. And this mouse coronavirus called mouse hepatitis virus has been studied as a model for coronaviruses for about 40 to 50 years now. And we use it because it's a safe model to use, but it is very closely related to a number of human coronaviruses and allows us to understand the biology of the virus while also not putting our students at risk of exposure or harm. In both of those systems, a lot of my research is focused on trying to understand, are there inhibitors that we can find to block these viruses? Are there features of the genome of the virus that we could target with some novel drugs? And then I've also dabbled in trying to help with finding unique approaches to develop vaccines for these different viruses. And a lot of that research stems from my experiences as a PhD student at Vanderbilt, working on coronavirus replication, which I know sounds really ironic because
I know.
Your PhD in coronavirus replication in 2013,
right
before all the pandemic hit, and then RSV was my postdoctoral work at Emory, and there I was working on vaccine design. So it's a lot of my recent past has kind of imparted the direction of my current laboratory.
We've kind of brushed over that a little bit, but let's talk about that. Like, what's going through your mind Because I think even me as a student, one of the things I struggled with as far as the science and research part is figuring out how what was doing would eventually connect to the real world in any meaningful way. And so, not that that's how you felt when you were doing your PhD, but when you're doing something on a little bit niche, and I don't know, maybe if it was niche at the time, and then there's this novel coronavirus that's kind of taking the world by storm. What's going through your head in terms of this is so closely related to what I'm studying? Like, how does that hit you?
Yeah, so the coronavirus community is really interesting. And you got to realize this was, from a science perspective, it was a relatively small community of scientists who were studying coronaviruses prior to the pandemic. Any great event, as soon as something big happens, then you have the bandwagon scientists, and everyone on the planet become a coronavirologist overnight, right? Everyone from the scientist who's been studying other viruses to people who are ecologists trying to find a niche or an area to contribute to this great pandemic, right? So for me, when I was going through grad school, there was another coronavirus that had just emerged called MERS, Middle East Respiratory Syndrome coronavirus, and it emerged in the Middle East. It has a really high mortality rate, about 30% mortality rate. So it was a scary virus, and for us, it was one of those, we'd seen SARS and we had read about SARS, which emerged in 2002, 2003.
Right.
Now there's MERS. So the coronavirus community was used to these emerging new coronaviruses. What we didn't expect, and which kind of caught us by surprise, was how well the virus spread. MERS and SARS could not spread asymptomatically. You couldn't spread it without knowing you had it. From a public health standpoint, that means if someone starts showing symptoms, you put them in isolation ward in a hospital, and you've cut transmission. With COVID, you could spread up to 36 hours prior to showing symptoms. And so you're walking around, you don't know you're sick, and you're just spreading the virus wherever. And that's a huge difference in transmission. And that's what makes a virus go from being a lethal one-off to now pandemic, is the spread potential. And so while the community of coronavirologists, and me in particular, while I wasn't surprised we had another coronavirus, we had already had 4 new coronaviruses, if you include COVID, in 20 years. This is a normal thing. What was surprising was the nature of how this thing acted in humans and how quickly it could spread from person to person.
Oof. All right. Well, can I embarrass you for a second?
Sure.
Okay. So I went on Rate My Professor, and students seem to like you. They say that you're amazing at breaking down complex concepts. You have a 4.5 rating on Rate My Professor. And I'm actually going to read one out because I think it was interesting. And it says, Dr. Stobart is amazing. He dumbs things down for you and does not make you feel stupid for asking any questions. He's very fun in the lab too and jokes around with students. He gives you the resources to succeed even though the class is hard. What's your secret sauce to teaching?
I think it just boils down to, let's be real. Let's be honest. Transparency is big in my classroom. I'm not going to lie to you. I'm going to tell you that the class is going to be hard, but I'm here to help you. If you put in your effort and your work, I'm here to help you. Again, I get the joy out of helping people understand things. So
right.
If the student comes in and they want to learn, I'm here to help them. And I think it's just connecting with our students is key, especially at a time right now where we're seeing so many different avenues of how do you teach a class. Out of the pandemic, we start exploring virtual learning, right?
Right.
Because we didn't have a choice. Right? Social distancing shut us down. So teaching a class through Zoom, right? Teaching class through podcasts, teaching class through articles, reading things online, using what's called a flipped classroom, where a student really goes and does their own self-learning, and then we use class time to reinforce concepts with practice. There's a whole bunch of new approaches over the last 10, 20 years that have just kind of spiraled into new avenues. And I think as we look at all these avenues, the key is meeting the students where they are, what they want. Not everyone loves me. Otherwise, I'd have a
well, that's the
5.0.
plus. Why it's not 5 stars. It's 4.5.
Right. Yeah, I think you accept that not everyone's going to be able to learn from you. Not everyone's going to kind of connect with you. But if you make a concerted effort to try your best, then hopefully in the end it'll pay off. And for me, it's kind of a lifelong journey to become a better and better educator. Right? And so I try to learn from my mistakes, and there have been many over the years, and also just listen to the students and find out what they need. So I don't know if I'd call it a perfect sauce. I think to me, it just seems the obvious things that you should do.
All right. Ready to switch things up again?
Sure.
All right. So we have a rapid fire segment that I didn't tell you about because I wanted to see the look on your face when you knew you were going to be asked some quick questions where you have to rapid fire some responses or share your immediate reactions to them. So that's the spirit of this segment. So I'll read the statements or ask you some questions. You go in with your brief response and we can kind of keep it moving.
Okay. Sounds good.
Ready to begin?
Yep.
All right. What's harder, being a student or being a professor?
I think being a student's harder than being a professor, because being a professor means you were a student originally. So I think I have a little bit of advantage because I know the perspective where the students are coming from in some cases versus a student who jumps into college and has no idea what they're walking into. Right? So I think that transition can be really hard, especially if your high school didn't prepare you well.
Right. If you had to pick one course as your favorite to teach, what would that be?
I really enjoy teaching parasitology, which is outside of my area directly. I decided to teach that course because our college hadn't taught it almost 30 years. And we don't hear about parasites a lot, but that's a whole other thing. But most of the developing world still deals with parasites regularly. We still have them in the United States, albeit clean water, clean access to resources helps cut that down. But it also is just a class where I get the joy of making people really squeamish. Right? Showing these nasty worms, these nasty creatures that get inside you and do all these horrific things, stuff that gives people nightmares. The look on people's face when I say, if you don't eat sushi that has been prepared correctly, you might get an intestinal worm that might make you feel really bad. And then you watch all the people who love sushi in the room just kind of cringe, So that, for me, that's the class I think is more fun to teach. And that's a recent class I started teaching at Butler. So
that's amazing that you brought that up, because I remember when in one of my classes when we learned a little bit more about parasitology, and I don't know if I'm remembering this correctly, there was something with the hygiene hypothesis and it being, depending on where you live, your immune system might skew one way versus the other way, and that explains things like allergy. And I remember my mind was blown when I kind of learned about that. So that's really cool.
Yeah, I mean, the rates of asthma, for instance, and allergies in the United States are significantly higher than what we see in developing countries. But the amount of antigens and things your immune system responds to are significantly higher in those other countries. So your immune system's constantly on alert. I don't know, this next thing I'm about ready to eat or drink is probably loaded in a bunch of things I don't want. So your immune system's ready to cook. Here, if you're constantly in this sterile environment, your immune system doesn't get that priming and that experience, that training, right, to look for things. And so it makes us more likely to respond overactive against these things. And that can lead to some of these diseases that we see, these hyperallergic reactions.
Right. And we might touch on that when we get to the anti-vaccine movement and kind of how some of the messaging is tailored around, maybe that's kind of the underlying premise for some of them. So we might explore that. You're hosting a dinner party with 3 of your personal heroes. Who's at the table? So you've got one seat and there's 3 other seats. Who do you fill those seats with?
Ooh, well, I'm a huge history person. I love history because it's a glimpse at looking at our past and seeing if we're unfortunately following the same trends. So I think I would pull on people from history. So from a U.S. politics standpoint, I think it'd be really interesting to have a conversation with Teddy Roosevelt and Lincoln. I think their pasts and their experiences and the stuff they went through are really interesting. So maybe 2 of those people. Going further back into history, I'm also a big fan of English history. And I think talking to and getting context from Elizabeth I or someone back then who's going through completely different times. So Elizabeth, as a virologist, she got smallpox in life. And there's all these stories, these written stories of people in the court who were just writing, and they're trying to be positive. But smallpox, when you survive it, leaves these pock marks all over your body, right? Horrible lesions. They're trying to describe her in she's a fair lady, but then the pox have made her as foul as one can be. And but the experience of you're surviving through a time when these viruses, I know we're going to talk about vaccines later, but we're talking about a time where these viruses are just killing people at a very young age. And if you survive, you're not just surviving with no blemishes, you're
Right, right,
surviving with that legacy left
right,
within you.
right. Like
And
quite
so,
literally battle scars
yeah, and then you
sometimes.
combine that with the culture and the history and all the things going on in that time. And she was a queen in the late 1500s.
Mm-hmm.
So, it'd be really interesting to kind of look through things through a historical lens. But there's so many other people, I mean, so many inspiring people that you could pick to be at that table who can give you unique facets. Like for me, it'd be connecting with someone and talking to someone who brings something in that I don't even have a context to think about, right? Right? Just what is life like through that perspective, right? I mean, I picked 3 people, for instance, who are from Western countries who speak English. I mean, picking someone from Asia, sub-Saharan Africa, who's gone through completely different environments and histories and cultures and challenges would be cool to also share a table with.
I agree.
It's a hard one to answer.
That would be cool though. I mean, that's why you have dinner 1. Maybe you have a dinner number 2. You can, or you get more chairs. We get more chairs,
Right.
bigger table. We figured it out.
Yeah, everybody's welcome.
Everybody's welcome. A hot take that you have about the work that you do that might ruffle feathers, but you're sticking with it with conviction.
So right now we're starting to move into exploring natural remedies. And in Western medicine, when you think about where your drugs come from, it typically takes the path of someone looks at a chemical that's either been studied before or is screening for chemicals in these huge giant chemical screens to see if something sticks and blocks a protein or an enzyme. And if that enzyme or protein is vital for a pathogen or for some disease path, boom, you start developing a drug from it. And then the chemists do their thing and they start chemically modifying it to make it the best they can. And then that becomes the new drug, right? But if you think about human nature and cultures, most of the world still relies on some form of natural remedies. And in fact, some studies have reported up to 20% of all plants and natural products likely harbor some biologic activity that could be therapeutically active. But here we don't really study what's out there, right? I mean, you go outside, you look at all these plants. Some of these plants might have chemicals in them, naturally produced, that could help us. Could be new avenues, new drugs. We just haven't really explored. Yet we have centuries, if not millennia, of history where people said, I've used this plant to treat this or that. And it's a bit controversial because I would say a lot of scientists are skeptical of, but just because someone has said that this will treat an eye ailment or this will treat a sore throat doesn't mean that it actually does, because there's no science to show that it does, right? But I think as we're looking at a number of potential issues in public health right now, such as antibiotic resistance, that's a huge one. Emerging infectious diseases like COVID, new viruses, new bacteria infecting humans, cancer, increasing rates of cancer. It's important that we have avenues to explore and develop new therapeutics. I mean, the antibiotic crisis that we're facing probably in the next 20 or 30 years is frightening. And a lot of people don't know about it, that we are not keeping up with resistance. And with each passing year, we're losing those antibiotics that we've relied on. For years, you go into a doctor's office and they say, oh, you got a sore throat. Here, take this med. Take it for the next 10 days. You'll feel better. The problem is that those diseases, unchecked without that antibiotic, can be really, really scary diseases. We take them for granted because you got that pill. But what if you don't have the pill? What if that med no longer works because the bacteria has figured out a way to get around it? So for us, we're exploring what types of biologic activity are in common plants. We started doing some work here in Indiana through actually a partnership with a member of a local Native American tribe and looking at what plants they've used. We've also partnered with the Indiana Medical History Museum, and they have a medicinal garden to look at some of their plants, exploring anti-cancer, antibacterial, and antiviral properties. And this fall, I hope, we'll be partnering with some groups in New Zealand who are producing honey and looking to see what kind of antimicrobial properties honey has that haven't been explored yet. So people may be like, yeah, I don't know about this. I don't think it harbors anything. It might be a waste of your time. I would push back and say, well, you don't know until you don't know, right? I mean, let's go ahead and do it. Let's see what's out there. There's a reason why people for thousands of years have used natural meds. Some of them work, some of them don't. I can tell you some of the ones we have tested, that no one has ever tested before
Yeah.
do work. There was a med that was used by the Native American tribe to treat sore throats that was derived basically from using a plant. And our study showed that it works against RSV. And so if you had RSV and you were using this plant medicinally, you were treating. Now, how well? I don't have that ability to tell you, but it works. It blocks the virus in our hands. And that's a cool finding. And it's also a new avenue that might lead to a therapeutic. RSV, we don't have any go-to drugs for RSV. You get it. They're going to put you in a hospital and you're going to sit in that bed really uncomfortable on oxygen waiting for that disease to pass, right? So I think that's the area that, for me, I would say, I don't care if people don't like this as an avenue. This is one that I think someone's got to explore it. And why not a undergraduate institution where we're looking for just pure science opportunities for our students to explore.
Right. And even from a use case perspective, and we'll get into with the kind of anti-vaccine movement, there is a case to be made in terms of providing more options for folks. If we're able to learn more about the naturally derived medicines, then people who would otherwise go untreated because of certain values that they had about medicines in the way that they define them might be more open to taking more products that you'd be able to classify as natural in the way that you're describing them. So I think there is some incredible utility in like going down that pathway to know, amongst the other things that you said, that added benefit.
Yeah, and the messaging is the key. I think, like COVID-19, I mean, I will tell you, there is so much literature in the scientific databases of people looking for every single thing on the planet to test it for COVID. And my message to people is trust science to do what science does. Science looks for fact. We're trying to understand how the world works. We're not just going to try publishing something because it has a political benefit to somebody. If I publish in a paper that this plant works and I've got the statistics to show that it's working, there is merit in that. And so if we tell you this drug, this med that you believe is working because someone said on an online platform that it's going to work, if we show it in a lab that it doesn't do anything, you have to trust that the science, I mean, that's what we're hired to do as scientists, is to answer questions and have what I would consider scientific validity. We bring in the statistics and the support to demonstrate that something works the way it does. We're trying to understand the world. And if you trust the science, it can lead you to discoveries that actually have merit. And so for us, we would love to find the next silver bullet that's going to kill the next coronavirus that's going to emerge.
Right.
But sometimes you don't do that. You don't find it. And sometimes, I'm not going to lie to you, if we don't have the story, I'm not going to go publish it as if we do. Because the data's not going to bear it out. And it won't get through peer review. So other scientists will read my paper and say, no, that's not how it works, right? So it's the messaging. And I think there's also disconnect. Scientists need to do a better job of explaining to the public how something works and why this does or doesn't work, right? There is a communication problem that created a lot of issues because the people who are communicating anything related to COVID-19, a lot of them were, for instance, not in the field of science, but could communicate in language that the modern person, that your average person can understand. And your average scientist speaks science speak, and they don't bring it down to the level. So who are you going to trust? Yeah, the person might have a nice PhD and glowing credentials, but if they can't communicate in modern English and in words that make sense, you're going to trust the person who's publishing the web article that may not have any merit to it.
Right.
Yeah.
That's a good point. All right. That brings us to the end. Did I scare you away? Am I going to keep you for the rest of the episode? How are you feeling?
Oh, you're good.
Okay. We're good to stay.
Yeah. These are normal conversation pieces for me.
Absolutely.
So what do we do with all of this? The science, the skepticism, the stories that don't always fit neatly into headlines or textbooks. Maybe it's about asking better questions. Maybe it's about listening to the data, to the experts, to each other. Dr. Stobart's journey reminds us that science isn't just about answers. It's about curiosity, humility, and the courage to keep searching, even when the world feels uncertain. Coming up next, we'll explore how viruses really work, demystify the science behind vaccines, and tackle misinformation that clouds public understanding. We'll also dig into the roots of the anti-vaccine movement and what it takes to build trust in public health. That's next time on the Public Health Insight Podcast. This show was edited by me, Gordon Thane, with additional editing from LaShawn Benedict. Sound design and mixing by myself and LaShawn Benedict. The original music from The Music Room, composed by Tom Fox, licensed from Johnny Harris. The cover art design for our show by LaShawn Benedict. The Public Health Insight Podcast is produced by PHI Media. Thank you for listening to the Public Health Insight Podcast, your go-to space for informative conversations, inspiring community action. If you enjoy our podcast, be sure to subscribe and leave us a rating on Apple Podcasts or Spotify. See you in the next one.